So thanks for coming. I will talk about testing web app with traffic control. When I mean traffic control, actually I mean only network traffic control, like adding some latency or limiting the bandwidth. I will do a short presentation of myself. I worked with container before. I worked on Rocket, and now I'm doing work on WeaveScope, on eBPF. And before I did some work with traffic control for different use cases. I work at Kinfolk, where I'm one of the co-founders, and we like to work on low-level Linux software, like this example, Rocket Systemd. We like Linux. Okay, you can find that. I will start directly with a demo. So the demo I will show you today is this application. That's a website. That's a sock shop. You can buy socks on it. And I will just quickly go through the feature to show you. So there is a home page. There is a catalog. Is it big enough? Yes. And then you can add things to the cart. And then there are your products there. So this application, this website, has been implemented using microservice architecture. What it means, it's running in a lot of different containers, and each container has a different purpose. There is the front end, I think it's running in PHP, and there is a lot of different backends for different databases and different services. So I will show you now WeaveScope. Should I make it a bit smaller? Or big? Yes. WeaveScope, that's monitoring and visualization tool. You can see all the containers running on your cluster. In my case, I have only one node running in a virtual machine on my laptop, but the idea is the same for more nodes. And here I can see, for example, I have a front end. And what's interesting is instead of seeing things in the list, you can see a graph. You can see what kind of communication happens between the different containers. So in this example, I have the front end, and I have a link to the user container talking to the user database container. So I see, if I click on them, I should be able to see the list of containers, the list of process in that, and then I can explore the container, and I can see the different connections that happen there. So what I want to test with that is a scenario where the network doesn't behave really correctly. As a developer, usually we have a good internet connection, so there is a low latency, good bandwidth, and especially when things are running in a virtual machine on your laptop, there is a good connection between Firefox and the virtual machine. So it's not easy to see bugs in the UI that could happen with bad internet connection. For example, here I go to the cart to see what I have. I just refresh the page, but it looks fine. It looks the items seems to appear pretty fast. So to be able to test that, we have developed a plugin on WeaveScope to be able to change the network setting to add some latency. And if I go, for example, to the catalog container, here it is. Here I have some controls which come with a scope. For example, I have something to get the logs, to get a shell inside the container. I could pause or stop the container, but what the traffic control plugin added to that was to add more buttons to make it slower. And here I have a button to add a 2-second latency. If I click on it, then things should be slower. So let me go back to WeaveSox, and I will press F12. If you don't know of Firefox, when you press F12, you have network console. And then when you reload the page, you should be able to see the different connection, the different HTTP connection to the web page. And here, most of them should be quite fast, but actually what you see here, the page seems fully loaded, but there was no items in the cart. And here it seems to be only one. And yeah, something doesn't work really as expected. Yeah, the image doesn't come very quickly. And that's something you can see here in Firefox. There should be some connections. Most of connection HTTP requests are quite fast, but like one of them, this one, take 8 seconds, more than 8 seconds. That's because I added a lot of latency to the catalog containers. And here we can see the request was actually to the catalog URL. And that's because the front end need to contact the catalog to be able to fulfill that request. So I will do it again. I will refresh again, and so you can see what happened here. So the page looks fully loaded, but it's actually there is no spinning wheel on Firefox to say it's still loading. There is the wrong sum here. It's $0, and it's a 1 items here instead of 2, and there is nothing there, and it takes a while to come. So a good user interface should have some user feedback to say it's still loading, to not confuse the user by saying there is nothing in the cart, because the user might be tempted to say, okay, I lost everything, I will try to buy again. So that's something you can test with traffic control by using with scope with the traffic control plugin. Here I will restore the settings. So now if I refresh again, it should work fine. Yeah, now it works fine again. And if I go to the catalog page, there is a similar bug. If I make it slow again, and I have some demo effect, but it's supposed to work. And I refresh the page, I click on refresh. And here it doesn't look really good UI in that case. So there is a lot of UI issues that will be benefit from testing with traffic control to see what happened in that case. Okay, that's it for the demo. I will go back to the slides. Just say a few words about the scope architecture. So in my case, I tested only on one node in a virtual machine on my laptop. But that's something which, if you have a website that scale on many nodes, you can use something like Kubernetes to scale up. That's what I have actually. I have Kubernetes on my laptop. And then you can have scope deployed on all the nodes of the cluster. And you have typically one agent on each node that will inspect the different connections. You will get the list of process, the list of container, the list of TCP connections. And then the agent will report that to the app. The app will get all the reports and merge them and be able to display them to Firefox. So that's why here I see, here I can see all the nodes on all the process, all the connections. In this case, I had a traffic control plugin that's run on each node, and the traffic control plugin will be able to receive orders from the command when we click on the buttons, and it will enforce the traffic control like 2-second latency. How does traffic control works? It uses a queuing discipline, or as they call network scheduler. It uses the network emulator 1, which is available in Linux since Linux 2.2, so that's really old and available, I think, everywhere. And it has some parameter. You can define a limit on the bandwidth. You can increase the latency. You can drop some packet. You can say I want to drop 2% of the packet, and you can correct packet. You can do a lot of things. Here in this talk, I just focus on the latency. I just add some latency to see what happened. Is there any questions so far? Yes?
This network emulator, is that a different piece of software, or is it something that's provided by the kernel, since you mentioned Linux?
Yes, that's a kernel module in Linux. And usually all the distributions package it. So it's, I think on Fedora you need to install, I don't remember the name of the RPM, but it's kernel module extra or something like that. And then when it's installed, it just works, the module gets charged. Loaded automatically. Okay. So when we want to test, we don't want to change the traffic control latency on everything. We want to do it on only one container, the one we want to test. Like in this example, I tested on the catalog. And it's possible to do that because the queuing discipline or network emulator is installed not globally, but only on one network interface. On each container are their own network interface. So here I can apply the settings only on one container or two containers, or I can choose, I don't have to have this setting globally. You have any other questions? Yes?
So can you run this automatically?
The question is, can I run this automatically in CI? With this exactly, no, but internally it uses the command line tool TC for traffic control. And this thing can be used in CI or in script. And I can show you the code actually, if I find it. So here is the GitHub repository on WeWork plugins, and it's the traffic control plugin here. I guess you can see here. And here it calls a function apply latency, but what it does, yeah, it's in another file, but what it does, it just do a system exec to execute the TC command with the correct parameter on the correct network interface, and that's something can script. Yes?
What about the incoming traffic?
It's possible to do in this. Oh, sorry. The question is, what about incoming traffic as opposed to outgoing traffic? In this traffic control plugin, I only care about outgoing traffic, but it's possible to do incoming traffic. That's a bit more difficult because you can more easily regulate what you send rather than what other people send you. But there is a kernel module called IFB for, I'm not sure what it means, IFB, I'm not sure what it means, but what you can do, you can redirect the incoming traffic to that IFB network interface, and then you can apply the setting there, and then you can, it will queue the incoming traffic. So if you use TCP, it will automatically adapt to the bandwidth or the latency, and then in practice, the application will see the correct latency. Another question?
You support Amazon and Kubernetes and Docker Data Center. Would it be difficult to enhance it for DCOS?
I've not tried it, but it should work as well because it's just container on network interface in the end, I guess. With scope, it rely heavily, I think, on Docker. But if it is container not based on Docker, we cannot use at the moment scope directly, but the internal things, the TC command line tool can be directly used. Thanks.
That's all the time we have.